Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to our lesson today. So we are still on the same topic with our last meeting. We are on um, using of numerical method to find root of equation, and now we have another method. This is called with regular Falsi method. Yeah. Okay. So this is the theory that you can just read if you want. Okay. But the point of this paragraph is like this. Yeah. Is this. Yeah. Okay. Yeah. So this is the formula. Yeah, the formula that we can use to find root of equation using this formula. So if we compare with um, bisection method, this method will be faster because we have a shorter algorithm to find the root. Yeah, and if you take a look on this paragraph, uh, one of power that we can find in this method is that uh, speed of finding the root, yeah, is faster. Yeah, if we compare with the p section, because yeah, as we know that p section is so need a lot of energy and takes time, but by using a regular Falsi, the time that we need can be shorter, so we can get uh, the solution, yeah, of the root of equation faster. Yeah. Okay, so the xt is the root of equation, and as always, more iteration means more accurate calculation. Yeah, so if we have like n equals to 5, and then the other one n is equal to 10, then um, this xt will be more accurate. Yeah, will be more accurate compared to when we only do 5 times of iteration. Okay. Okay, so let's we go to the algorithm. So this is the steps that we have to understand first if we want to use regular Falsi, yeah, to find root of equation. Okay, first one, we start our calculation by by deciding or choosing the value of xn, and in this case we can randomly choose xn. It can be 1 or it can be 2, it's up to you. And then after we decide the value of xn, then we calculate, yeah, the result of fxn. Yeah. So fxn is a function of the function, yeah, that when we put the xn into the function f. Yeah, so if let's say we have fx equals to x plus 1, yeah, then if the x equals to xn, then the result of fxn, yeah, will be xn plus 1. And if our x is equals to 1, so this value will be f1 equals to 1 plus 1. So we got 2 here. Okay, after we calculate our after we decide the value of xn and also the result of fxn, then we move to next step. um, we we change the xn with xn plus 1, so the xn plus 1 uh, also random. Yeah, you can just choose the value of the value of xn plus 1. Then the same with the previous step, we put xn plus 1 into the function, and if the value of fxn multiplied by fxn plus 1 equal less than 0, yeah, so we can continue to the next step. But if this value is not less than 0, then we have to find another xn plus 1 until we got the multiplication less than 0. Yeah. Okay, so uh, to get value less than 0, the value of fxn must be negative, and the value of fxn plus 1 must be plus, or vice versa. The fxn must be plus, and then the fxn plus 1 must be minus, yeah, because minus multiplied by plus, it will get minus, and plus multiplied by minus, it will get minus, yeah, and minus is less than 0. Okay, let's say we got this condition, so we can continue to the next step. We calculate the value of xt. Yeah, I put the xn here and then minus fxn times xn plus 1 minus xn divided by fxn plus 1 minus fxn. Yeah, after we got the value of xt, then we put the value of xt into the function, so we get f xt. Yeah, after that we calculate the value of fxn, which is actually the value of xn is already obtained because we calculated first at the early stage of the step, and you calculate with this value, the value of fxt, and if the value of this operation is less than 0, then we go to this step, and if we do not get less than 0 for this calculation, then we move to the step. Yeah, so in this step we have two conditions. If yes, if your calculation complete this situation, then you go to this point, and if you don't get it, you have to move to this condition, and after that you have to ensure that the value of fxt is less than or equal to the error that already stated from the problem. And if your fxt is not less than the error, then we have to recalculate from this point until we get the value that less than the error. Yeah, and if you get the calculation of fxt less than the error, then we can go to the next step, which the xt is the root of the equation. Yeah, so xt, the last xt is the root of our equation. Yeah, and stop means you finish with the calculation. Yeah. Okay, so this is the flow chart that we have to understand first before we use regular falsi in our calculation. Yeah. Okay, so yeah, this is the example of using regular falsi to get root of equation. But I think we are going to do this not in this video. So in this video, we only focus on the theory and and understanding the flowchart of regular Falsi method. And after this video, we are going to understand what the example says. Yeah. Okay. Thank you for your attention for this video, and we are going to continue this explanation on the next video. Thank you.